Okay, so today what we're going to do is we're going to learn about Z-scores. So the big idea about Z-scores is they kind of deal mostly with normal distributions. And when we have these normal distributions, we should remember that these things kind of look like this. And they're always centered at the mean. And we count by the standard deviation. So we kind of increase by these standard deviations each time as we go out. So for this first one, they say we have a population with a mean or an average literacy rate of 60%. So we have this normal curve, and our middle is 60%. And they say our standard deviation is 3%. So we count by 3% more, so this would be like 63, this would be like 66, and this would be like 69 if we keep going. And then they go, what is the one standard deviation above? Oh, well, one standard deviation above the mean is this 63%. And then they go, what's 3 standard deviations? Well, we counted that out too, because we go 63, 66, 69, so that'd be 69. And then what's 2 standard deviations below? Well, then instead of going forward, we would count backwards. So this would be like 57. And this would be like 54. So it'd be 54%. So as we think about these standard normal curves, that's kind of where people fall. If you're 2 standard deviations above the mean, then you would be in this 66th percentile here. Okay, let's try the next question. So in this is one, it says Roland scored an 81% with a Z-score of 2. And in English, and we had a 76% with a Z-score of 3 in math. In which subjects did they perform better? Well, when you look at this, Roland scored better or had a higher percentage in English than they did in math. But what Z-scores tell you, Z-scores tell you how many standard deviations above the mean there are. So when we're looking at this one, well, this was just 2 standard deviations above the mean. So the average was here, and they're just here. And this is our English one. But in math, even though their score was lower, if the average was here, they would all the way be up here or 3 standard deviations above the mean. So even though the mathematics score is lower, they actually did better in math because everyone else's scores were lower, like it was a harder test. So math was the class that they did better in because they were higher up or they were further away from the average. Okay, so when we're reading these things, these scores tell you how far they are away from the mean. So if you have a Z-score of 3, that's 3 Z-scores above the mean, and that's pretty high. Most times if you remember looking at some of those Z-tables, this would be like a large percentage. Okay, so let's try the next question. Okay, so now we're going to calculate a Z-score. And if you remember before, how you calculate these Z-scores is if we have what we call our standard normal curve, that's something like this, and I want to convert it to a mean of 0 and my standard deviations to be 1. If I want that to happen, oops, and I kind of drew my 0 funny. So if I want a mean of 0 and my standard deviation be 1, how we do that, if this was like 50, and maybe this was like 50, like counting by 3s, how we convert that is we say you take your value minus your mean over your standard deviation. And that will convert all of the numbers, or any possible number you could have here, into these. So we have a score of 200, which is our x. I have my mean of 140, so I'm going to subtract my mean of 140. And I have a standard deviation of 20, so I'm going to divide by 20. So my z-score in this situation would be 60, if it's going to write. Oops, lagged a little bit. There we go. 60 over 20, which would be a z-score of 3. Okay. So when we're going about and we're doing this, just make sure that for your z-scores you're using x bar minus mu. Okay, let's do 2 more quick questions and then we should be good. Now we're going to think about these z-scores in a little bit of a different way. Let's say you have the z-score. So they told you that your z-score is 3. So if you're thinking about your curve, this is what this means. It means I have my standard normal curve, center at 0, we're 3 above, that's where it's sitting. Now the problem is, we want to know what the test score was initially. So, I mean, we had a mean of 71 here, and this is now 3 standard deviations above that mean. Oh, well, the standard deviations, this here was just counting by ones, because like this is the standard normal curve, so this just counts by like 1, 2, and then up to 3. This one, in our original one, was counting by 2s. So 1 tick mark above would be 73, 2 tick marks above would be 75, and 3 tick marks where we're sitting would be at 77. So that would be our answer. If you want a formula for how to go backwards in the z table, how you go backwards is you say, okay, I know that this is my formula to go this way. So let's write that formula out. If you want to go backwards, well then you just reverse the formula. So you would just, if we were going to solve this kind of like how they probably thought about solving this problem, we would say, well, we have, whoops, having all the kinds of issues with this thing today. We don't know our x score. We know our mean is 71, and we know our standard deviation is 3. And then, our standard deviation is 2, and our z-score is 3. So how you would undo that is instead of dividing by 2, we'd undo that by multiplying by 2. I'm scared to move this, but we'll see if it works. And then we're going to have x equal minus 71 equals 6. And then we're going to add 71 to both sides. And that is how we can say, oh, look, our original score was 77. So there's 2 ways you can think about it. You can kind of reverse all their operations. So instead of dividing, you multiply, and instead of subtracting, you add. Or you can just think about, oh, this is my standard normal curve. How would it look if it was in its regular normal curve again? So just make sure you're thinking about it this way. Let's do one last problem. So let's put all of our ideas together. So this is where it really comes out. Let's say Aaron and Marge are taking 2 different exams, like an SAT and an ACT. I know these can't be scores on SATs or ACTs, but let's say they are. Like Aaron's taking, I don't know, let's make up an exam name. Let's call it the MAT, the M-A-T. And let's say Marge is taking the NAT, the N-A-T. And we're trying to see which one did better so we know which one to admit to a certain college. And when you have this situation, z-scores are really helpful because whoever scored higher on that normal curve did better. So we need to turn this one into a normal curve with a mean of 0 where we're counting like this for our MAT score. And we want to turn this into our normal score with our NAT score. Again, I just made these names up. I don't know what they're really called. So we can compare, just like we did on one of our very first examples with math and English, like which test did they do better on. So when we do this, we'd like to know Aaron's z-score. So for Aaron's, this is Aaron's and this is Marge's. So for For Aaron's, what we would end up doing is we're going to use our formula. And we'll do the same thing for Marge's so that we can compare who did better. Because they took different exams. And when we do this, we're going to find, 12.3 minus 6.7 divided by 1.4. Aaron did pretty well because he was, I think I updated the pen again, he was 4 standard deviations above the curve. And then when we look on this other one, Marge did pretty well too because she was 2.5 above, but obviously this score, Z-score, is a lot higher because it's way over here, where this one's kind of sitting in the middle right here. So Aaron did a lot better than Marge, and that's how we can kind of use this in real life. They use this to compare your SAT and your ACT scores and a lot of other exam scores. So these are the Z-scores. If you get stuck with anything, please just ask.